Have you ever just stopped and looked up at a giant airplane, a 500-ton machine, and really wondered, how on earth does that work? How does that massive tube of metal completely defy gravity and just hang out in the sky? It feels like it should be impossible, but it's not magic. It's pure physics. And today, we're going to break it all down.
I mean, it really seems to break all the rules, doesn't it? We spend our entire lives glued to the ground by gravity, and yet these metal giants just soar effortlessly above us. It has this almost magical quality to it, but today, we're going to decode that magic and show you exactly how it's done.
You see, the secret to flight isn't just one thing. It's actually a delicate balance, this constant, invisible tug-of-war that's happening up there in the sky. It's a battle between four fundamental forces, and if you can understand this balance, well, then you can understand flight. All right, so who are the players in this tug-of-war? First up, you've got weight. That's just gravity, of course, always pulling the plane down towards the Earth. Fighting directly against it is lift, that amazing upward force the wings create. Then, pushing the plane forward, you've got thrust coming from the engines, and the one force trying to slow it all down is drag, which is basically air friction pushing back. So it's this constant battle, up versus down and forward versus back. Now, for a plane to just cruise along nice and steady, these forces have to be in a perfect state of equilibrium. Lift has to generate the exact same amount of force as the plane's weight, and thrust has to be perfectly matched against drag. The second that balance shifts, if lift becomes greater than weight, boom, the plane climbs. If thrust overpowers drag, it speeds up. It is all a beautifully precise balancing act. Okay, so that brings us to the biggest question of all. Where does lift actually come from? It's kind of the most mysterious of the four forces. And the secret, the real magic, is hiding in plain sight. It's all about that simple, elegant curve of an airplane's wing. So here's how it works. As the wing slices through the air, that curved top shape forces the air flowing over it to travel a longer path, which makes it speed up. Now, the key insight comes from a law of physics called Bernoulli's principle, which says that faster-moving air has lower pressure. It's that simple. So you end up with a low-pressure zone on top of the wing and a higher-pressure zone underneath it. And that difference in pressure creates a powerful upward push. And that, my friends, is lift. So let that sink in for a second. The plane isn't just using brute force to push air down. No, it's much more elegant. The wing is creating a pressure imbalance. You've got faster air and lower pressure on top, slower air and higher pressure on the bottom. And the airplane is literally pushed up into the sky by the higher pressure from below. And just how powerful is this force? Well, get this. When you run the numbers for a simple glider, its wings can generate over 17,000 newtons of lift. To put that into perspective for you, that's enough force to lift an entire car clean off the ground. A car! All from just shaping how air flows. It's just wild when you think about it. So, if you're a pilot, how do you control this incredible force? Well, your main tool is something called the angle of attack. And don't let the technical name fool you. It's simply the angle that the wing is tilted at as it meets the air. By pitching the nose of the plane up just a little bit, a pilot increases that angle, and they can generate more lift. But there has to be a limit, right? You can't just keep tilting the nose up forever to get more and more lift. What happens when you push it just a little too far? What happens when you get too greedy with that angle? Well, this is what happens. If that angle of attack gets too steep, the air can't hug that smooth curve anymore. It separates. It becomes a chaotic, turbulent mess. And that beautiful pressure difference that creates lift just collapses. This is called a stall. And it's crucial to remember, a stall has nothing to do with the engine failing. It's a purely aerodynamic event. It's all about the wing losing its grip on the air. So we've covered lift, the hero force that gets a plane in the air. Now let's talk about its arch nemesis, drag. This is that pesky force of air resistance that is constantly trying to slow the airplane down. For engineers, fighting drag is a never-ending battle for more speed and better fuel efficiency. And trust me, they have a whole bag of tricks to fight it. Every single part of a modern aircraft is designed to be as slippery as possible. The body of the plane has that streamlined teardrop shape. The landing gear tucks itself away to get out of the wind. Even the paint is specially designed to be ridiculously smooth. And you know those little fins on the very tips of the wings? Those are called winglets, and they do something brilliant. They break up these little energy-sapping whirlpools of air that form there. All right, so we've got lift fighting weight and thrust battling drag. But real flight isn't just about winning these individual battles. To achieve that smooth, stable ride that we all want, all four of these forces have to work together in perfect harmony.
And the one point where this whole symphony comes together is the plane's center of gravity. You can just think of it as the aircraft's absolute perfect balance point. Designers work incredibly hard to make sure all of these massive forces pivot and act predictably right around that one single point. If they get it right, the plane is stable and a dream to fly. If they get it wrong, it's a nightmare. And that's where the pilot comes in. They aren't just a driver. They are the master of this balance, the conductor of this amazing aerodynamic orchestra. Every single climb, every turn, every descent is a deliberate act of unbalancing these forces for a moment and then perfectly, skillfully rebalancing them again. So after all this, it leaves us with a final thought. What do you think? Is an airplane just a brute force machine using powerful engines to muscle its way through the sky in defiance of gravity? Or is it something more elegant, a brilliantly designed object that's actually partnering with the air, using the laws of physics to perform an elegant, weightless stance in the sky? It's something to think about the next time you look up.